I'm going to speak about one project in particular, and I'm going to demonstrate the use of BIM as a collaboration and coordination tool. The project in question, most of you will recognise from the first image, is the West Kowloon Terminus in Kowloon, which is being managed by the MTR and built for the government. The first part of my presentation will talk about the facts and figures of the building, so you get a sense of the scale, and it is massive. I will then talk about why the MTR have implemented BIM, and this is an MTR initiative. I'll show you some of the results of the BIM process and the collaboration that it has entailed. And I'll finish up in my presentation by demonstrating how the contractors have taken on the BIM following the MTR's initiative. So the MTR has started the ball rolling, and the contractors have picked up and gone with that ball. So let me show you first of all some facts and figures about this very large project. Some of you will recognise this image. This is an image of the famous roof looking towards Hong Kong. The roof is basically the pimple on the elephant. I'll leave out the last piece. And the actual elephant is massive. It's 400,000 square metres gross floor area. The floor plate of one level consists of 76 drawing sheets at 1 to 100 scale. So anybody who's built anything will realise that 76 drawings for one floor is massive. The building is 250 metres wide and 600 metres long. Its cross-section is predominantly below ground. So there are 4 levels below ground, including 15 platforms for intercity rail and high-speed rail. It also includes integrated highway structures. So the integration of the highways department into the MTR project is fundamental. The roof, which is publicised heavily on ADAS's website and the MTR website, involves some very complicated geometry and some very beautiful architecture. Internally, there are some very, very large columns supporting the roof. Now, to give you an idea of some of the initiatives, the roof is of such a complexity that it can only be modelled in 3D. It is impossible to document this roof on 2D drawings. So this model is the architect's design model for the roof. So this has been constructed in a piece of BIM technology called Revit. This little animation just shows you the scale of the roof. As we pan out from the building, you can see the aluminium panels, you can see the glazing panels. And this was all done by the architect at the design stage. The innovation is that the MTR and the architect have given this model directly to the contractor. So they haven't tried to resolve it down to 2D coordinates, they haven't tried to just give them drawings, they've actually given them the geometry. And we believe it's a first in Hong Kong to see it going that way. So the geometry has been handed from the design team to the contractor. Underlying this architecture is some very complicated structural engineering, and as a structural engineer, it's my favourite part. So there are 3 primary steel trusses. The structural engineer has constructed a wire frame for their analysis. So this little animation shows you the actual construct of the wire frame. Using the BIM technology, we can assign all the members to this actual framing. We can calculate deflections, we can work out buildability. So the animation will show you the primary trusses, and those trusses are then laid out in space. Again, the structural engineer has given all of the engineering geometry to the contractor for their construction. So there was a precedent at the beginning of the project that we had a complicated geometry roof and that those models were being given to the contractor. When you look at the actual roof in relation to the construction of the building, it's not a simple cap on top of a structure. This roof involves integration at 4 different levels of structure and involves erection of steelwork at different phases during construction. So the interaction between the cladding and steel is complicated, and the interaction of the frame with the concrete is even more complicated. The BIM model was originally conceived for the roof. But then, when you look at the project in more detail, it's extremely complicated in relation to interfaces. So we have this complicated arrangement of 3 civils contracts. 811B in the north, 810A in the middle, and 810B at the south at West Kowloon Cultural District. 810A encompasses the roof. Austin Road on the bottom, Jordan Road in the middle are the civils boundaries. But the building services are divided into 4 separate contracts: ECS, MTR control systems, electrical, and a contract for all the piping for fire services and plumbing and drainage. Each MEP contract covers all 3 civils contracts. So the interaction between the mechanical, electrical, and building services contract is extremely complex. And then to add even more entertainment, there are 4 different system-wide contracts, including lifts and escalators, etc., which covers these. So there are a number of very complicated and very intricate interfaces. So the MTR decided that they would adopt BIM primarily to de-risk the design and construction of West Kowloon Terminus. Now, what do we mean by de-risk? They wanted to provide a collaboration and communication tool for their own project management, design management staff, for the design consultants, for the contractors and other project partners. So the BIM was seen by the MTR to be a tool they could use to effect communication and collaboration. It was also set up to identify and resolve any missing, erroneous, inadequate or design information. How many people here have found problems on site because of a missing piece of information on a drawing, a conflicting piece of information on a drawing, or a missing drawing entirely? A few hands going up. I suspect there's a few more. So the idea was to try and proof the drawing. We set out at the beginning of the MTR some key objectives. They want to minimise abortive works, big goal. They want to avoid project delays, a very challenging goal. They want to mitigate against additional costs, another challenging goal. And they want to prevent wasted resources for both the client and the contractor. This is what was set out at the beginning, and this is what we set out to achieve. So what was the scope of the BIM and how was it documented? The MTR basically said in their tender documents for BIM, you must model everything. There was nothing left to chance, everything has to get modeled. So they basically issued a contract to do a review of 15,000 drawings for all disciplines through the station. A massive, massive undertaking. That undertaking involves the entrances. So here you can see the BIM model of entrance D and the main feature roof. It involves the highway structures. So here you can see footbridges, underpasses, pile foundations, interaction with the existing structure. We have to model all the building spaces. So we have delivery routes, headrooms, staircase alignment headrooms, escalators and escalator spaces. So as you get into the specification, you realise there's a lot of detail required in this model. So we commenced the modelling. We put a team on site working directly with the design management team and construction management team and set to building, first of all, the structural model. So this is a clip from the actual structural model. If you're not colourblind, the red is a problem area and the green is good to go. So we've used a colour system in the actual process to identify where there's coordination problems and then document them. The technology allows us to cut live sections through the model. So we can actually interrogate the model, we can drill down into, in this case, the platform level, and we can look around the model and see what's happening. This tool is available to the design managers, the construction managers, the design consultants, and even the contractors. So it's not limited to a couple of BIM guys sitting in a corner office. We can look at problem areas, we can try and identify what those problems are. So the structural model is made up of predominantly in situ concrete and also a substantial amount of steelwork. Moving from the structural model, we get to the architectural systems. So as you go through the architectural model for the station, you'll see platform furniture, you'll see guardrails, you'll see the headroom as the yellow box, and then you can climb the escalator. There's a column in the way. So we have to find out why there's a column in the way. But not only can you walk through the space, we can actually live cut sections through the actual building. So we can get to understand the complexity of the escalators to move people through this project. It's extremely complicated navigation. So we can use the technology to look at the ceiling spaces, the escalator spaces, the relationship between different escalators and different levels. And this is a very powerful communication tool dealing with resolution of design problems, understanding why is there a column going up to the escalator, where does it come from, where is it supposed to stop, where's the detail to actually terminate that column. But then again we move on, and we then put all the building services in. So the building services, originally it was conceived by the MTR that we would do it from the design consultant's drawings. We were appointed at the beginning of construction. It was very quickly decided that it would be more beneficial to work in collaboration with the E&M contractors. So we're now building models with the E&M contractors to resolve coordination problems, SEM layout problems, CSD problems. And this model shows you the complexity of the E&M systems inside the building. So the orange is cable trays, the green is drainage pipes, the blue is the ECS system, and you can kind of get an idea of the structure in the background. Those of you with a keen eye will realise there's a lot of clashes in this system in early days. When you integrate all these models together, you can look at the systems inside the building. So you can see the architecture, you can see the openings, you can see the mechanical ductworks. So here we're looking at the platform level. The guys have modelled the tracks to make it look like a train station. You can look at the ceilings, and then we can look into the ceiling voids. So we can interrogate the ceiling voids. How is the E&M laid out? Is there clashes? Is there coordination problems? We can cut through the building, so we can actually go above the roof. and we can look at what's happening along an alignment. So we can look at how the pipes are stacked, we can look at the cable tray arrangements, etc., etc. This is the BIM model in action. So this is what the MTR wanted, this is what we've created. And people will always say, well, it's just a 3D model, it's really cool to look at. Where's the value? To review 15,000 drawings took a team of 20 people. To do complete detailed clash analysis took a team of engineers and architects working with the BIM team. That team have identified over 2,500 RFIs through that process, which includes up to 8,000 queries. So one RFI may include 3 or 4 or 5 queries. So we've identified 8,000 issues which need to be considered, documented, potentially resolved. Some examples. The structural engineer designing the framework for the vent building, a separate structural engineer designing the piers for a bridge structure. Their alignment doesn't quite match. The model will identify a clash. In this case, we were able to reconfigure some of the structure for the vent building, problem solved. But actually being able to see 2 different engineering disciplines interacting was very powerful. This is a drainage drawing layout for the PTI, and the team have identified that a lot of the drainage pipework, the levels and inverts, are clashing with the tie beams required for the foundations. So we either have to amend the invert levels of drainage or amend the actual tie beam levels to solve that problem. Putting it in this context, labeling different manholes, identifying grid lines, makes it easy for the engineers to understand the problem. Putting it on a drawing makes it relevant to the guy who drew the drawing. What's on that drawing? Oh, that's my drawing, I've got to change this, I've got to change that. So we try and communicate back to the engineers in 2D. This is a very common problem, but not easy to find in a 2D drawing. This is the yellowish area is a headroom requirement for a ramp. You can see the sloping structure, and oops, we've just hit a piece of concrete above our heads. You cannot find this on a 2D drawing unless you've drawn sections in every single grid line through the building, which doesn't happen. So the model includes headrooms as solid objects. So we can find this problem, and we can fix it. Getting into a bit more detail, access ways for getting in and out of plant rooms, cat ladders going through aluminium cladding panels. We need to basically design the cladding panel to allow an access hatch, not a big problem. But what happens when the cat ladder is outside the actual envelope of the building? That cat ladder needs to be repositioned. So that cat ladder is drawn on one plan. When you see it in the context of complex geometry, you realize, oops, that doesn't work. That problem has been solved. Getting into a bit more detail, it's not just about physical clashes. Looking at the actual structure, again, this is looking at the area around the roof. This is a very complicated piece of concrete. It involves transfer beams, it involves shear walls, and in this area there's a requirement for an air duct formed in the concrete structure, but on review you can see there's actually a wall blocking the air duct. So we go through the model in some fine detail, and we produce on a regular basis a clash analysis report. Now, the clash analysis report includes information about what drawings were used to produce the model. It includes information about what's in the model, what's being checked. It includes snapshots of the problems that have to be fixed. And it includes a diagnosis of the progress so far. I'm an engineer, I have to put a graph in my presentation, so this is one of 2 graphs. This shows the number of RFIs on a month-by-month basis. The first peak is the architectural and structural review, which was done in the first 4 months. At the peak, we were raising 250 RFIs per month. There's then an ease off where we've basically loaded the design team with hundreds of questions. They've gone off to review their drawings, they've gone off to make changes to the drawings, and now they've come back. We've also engaged now with E&M contractors, so the second peak is the next trench of drawings coming from the design consultants, plus the engagement with the E&M contractors. So we're now finding the next round of issues and problems. In context, the blue line is the amount of RFIs raised on a cumulative basis. The red line is the resolution of those problems. In an ideal world, the gap would close to 0. And you can see that at the beginning we were raising more RFIs than the design team could handle. Towards April, the design team came pretty close to closing the whole thing out, and then we've started to accelerate again away. So you can monitor the progress of the resolution of problems just by looking at some simple data about how many RFIs are outstanding, where are those records. But it's very easy for us to stand in the glass house and throw stones. The collaboration comes through workshops. And our team are all here, Stuart's here, William and Mark are all here. They spend half their time in discussions, somewhat informal, sometimes structured, arranging meetings with the architect, the structural engineer, going, hey, We found a problem, we need to sort this out. Sometimes it involves quite a lot of head scratching. There's quite a lot. Where does that problem come from? How am I going to solve that problem? Can you turn the model around? How are we going to solve this issue? And very often it involves a combination of looking through tens and tens of drawings. Oh, that's not a clash, yeah, that's definitely not a problem. Trying to find out where the problem is in the drawings, and then get the aha moment. Ah, that dimension is wrong. That should be this X, Y, and Z, or I need to change that, or I need to amend it. This is the trick. This is a real secret to the BIM process. The model is no good sitting on a computer in our office. It's very effective in a collaboration workshop. And the MTR team, Terry Martin, who's the key figure in all this, is very prominent at driving collaboration, driving coordination, and getting the design team involved. So the engagement has been very predominant with the MTR, and they've been pushing it very, very well. So the MTR have now appointed all the main civils contracts, all the main building services contracts, and they're looking at ways of engaging and cooperating with the contractors. So the contractor cooperation is fundamental in all this. They're going to build a building, they need to know what they have to solve. In relation to the complicated roof, the 810 AJV, the Leighton Gammon JV, have appointed Alfasi, a steel fabricator, to do the steel detailing. So they've taken the geometry from the design stage, they've brought that to a steel detailing application, and they've actually put in connections, all the correct member sizes, etc., etc. The package for all the aluminium cladding and glazing has been awarded to gardeners. And Gardner also have to model everything in fine detail in 3D. Brackets, plates, angles, cladding rails, stiffeners, the whole shooting match is done in 3D. Under the 810A contract, the BIM team are then integrating these two different systems. So here you can just about see the brass coloured or bronze coloured Gardner requirements, which are then fed to the fabricator, who then incorporates them on their shop drawings, and then hopefully delivers all the plates in the right place to site. So when the aluminium cladding guys come along, they're drill fixing or clipping into all the right locations. So there's a very strong integration on the roof between the steelwork system and the cladding system. But the contractor has now taken the BIM to another stage. So another live firing exercise, we're looking at the construction of this roof and in relation to the construction of the basement. So the contractor is able to take the concrete model that we've built with the MTR, with its steps, with its openings, with its beams, with all the stand-downs, and then cut it into pieces. They can then look at the excavation, which is these big blue blocks, and on a day-by-day basis we can identify a construction sequence that allows us to get a tower crane installed, allows us to get cast concrete in certain areas in a logical sequence, reposition the tower cranes or add in tower cranes, and then get the superstructure going for the steelwork. So this is a series of snapshots taken from the model based on the construction program. And this can be done in infinitum, checking different sequences, trying to find an optimum sequence. It can then be used to communicate to the site engineers, the contractors, subcontractors, the method for how they're going to put this thing together. Our objective on the CSD and SEM is to take it from simple pipes and ducts and actually incorporate hangers on all the other detail required in the E&M system. So we've got the pumps, we've got all the cable trays, we have all the fire sprinkler system, plumbing and drainage system, all the chilled water pipe, and then we run the analysis. So this little video shows you a clash analysis. And what the software is now identifying is pieces of pipe clashing with hangers for chilled water pipe. Now it may seem like a complete nonsense just trying to find small details. On one of our previous projects, some of the biggest problems on site were caused by hangers supporting substantial pipework. So we're now driving to try and put as much detail in the model as we can that is sensible to solve these coordination problems. Here you'll see some electrical ductwork clashing with a duct. So the model allows us to get down to a very, very fine level of detail. And some people argue, wow, you're just wasting your time. These guys will solve this problem on site. What's all the hullabaloo? But if we can actually get confidence that the whole thing works in a plant room, we can improve productivity on site, we can avoid delays on site, and we can avoid conflict on site. So the model will identify a clash between a ductwork system and a cable tray system, but more importantly, it can identify clashes between pipe hangers and pipe rails, between pipes and between other systems. So we can drive a lot of detail into the model. On 810A, the contractors are taking it even further. They've come up with a potential solution for the construction of the walls, which involves concrete in situ to a certain height, and then blockwork infill panels above. So we're looking at a system of two materials in the wall. So the contractor has taken the BIM model from the MTR and they've started to apply different materials in different positions. So depending on fire rating, depending on the type of wall, depending on the availability of supporting structure, they're going to reconfigure the wall. Once that's been done, we can use the software to automatically generate all the wall elevations for site. So we can generate 1 to 20, 1 to 50 drawings to allow the contractors to actually build the walls, put the SEM openings in the right location. So again, the contractor has taken the benefit of the MTR's initiatives on BIM and driven it out onto site. So based on our benefits so far, we've identified many problems. Through collaboration and coordination with the designers and the contractors, we're solving those problems on a continual basis. We have a lot of work ahead of us. The job, as you know, is pretty much under construction. But the MTR have benefited and seen benefits so far. And TC Chu and his team have then propagated BIM further into MTR projects. Anybody who ends up working on SCL projects, there is now a full-blown BIM specification for all SCL construction projects, and it reads like this. The main contractor, not the MTR, must produce BIM from the consultant's 2D drawings. What does that mean? It must conform with the MTR BIM standards and level of detail. And the MTR have got a very good document which identifies exactly what needs to be in these models. It needs to include the civil, architectural and all building services. And the models must be produced within 3 months of contract award. The trigger is they want to find the problems early and the MTR want to collaborate and solve those problems. So it's not for the contractor to keep it all a secret and tell you later. They want to know the issues, they want to see the models, they want to see the detail. The implication and the other requirements is the contractor must advise the MTR of any potential problems identified in the models. So they're using BIM as a collaboration communication tool. If there's a problem on the drawings, please come and tell us and we'll help you solve it. Once they go through that process, it will involve dams, it will involve RFIs, it will involve changes to the drawings. The contractor has an obligation to maintain that BIM model to include any site instructions and any design changes. So as things come through the mill from the architect, the engineer, the model must be kept up to date. And then at the end of each project, the MTR are expecting an as-built model back. And the MTR are looking at facility management, they're looking at integration of data, and all of these things. So the MTR have benefited so far in West Kowloon Terminus to the point that they're now mandating on future contracts. And they're putting an onus on the contractor to take on the BIM and use BIM for collaboration. What have we achieved? So far, we believe we've identified and resolved a large number of problems prior to construction. We won't stand here and tell you we've solved them all. We won't stand here and tell you we've found them all, but we have done a pretty good job finding a large number of them. We have worked very hard at collaborating with, and not throw stones at, the MTR team, the design consultants and the contractors. And it's very important that it's a collaborative environment. It's very easy to turn and say, your drawing's wrong, you go and fix it. We want to actually show them the problem, we want to explain the problem, we want to offer them solutions. The BIM process is very much a collaboration process. The MTR have identified one big benefit for themselves. Their team, their people, their engineers have gone through this process, they've been trained, they've been using the technologies, they're now looking for it on their own projects. So the people in MTR are developing their own skills. The MTR now have a tool for visualization, communication and collaboration. And following on from Thomas's presentation regards productivity, we actually believe that there's an indirect application for this. It reduces abortive works on site. It eliminates time spent and replying to RFIs. You'd be amazed how much time engineers on site spend just generating RFIs. And it minimises late changes by the owner. So the MTR will have less design changes imposed on the contractor during the process. So the MTR are committed to BIM. They're not the only consultants or clients. We have the Airport Authority using BIM on Midfield Concourse. Ada Fung and the team at HA are using BIM on all of their current construction projects that have been mandated to use BIM. And the private sector is also leaping into BIM. So all the major developers, including Hysan, Henderson Land, Swire, are all using BIM on their projects. So anybody who's sitting in the audience who believes the industry is not ready for BIM or there isn't a skill set in the industry, all the major owners, most of the architectural engineers have experience, the major contractors are all using it, and the main industry of subcontractors are also involved in the process. So the industry is experienced and willing to grow into the domain. But it must be driven by the government and it must be driven by the clients. So I'll leave you with that talk going to your lunch. Thank you all very much.